Well, thank you for having me. Yeah, I love these events. I remember vividly some of the first ones I came to, learning about Dyson spheres and reconstituting the matter of Jupiter into computronium, Eric Drexler, and the whole nano future. It's just been a brain spa, as I describe it, and so I love it. I'm glad to be back. So the topic is maybe more prosaic than I normally like to speak about at events like this. Like, this is an investor group, and so I normally like to talk about entrepreneurs and technology trends, not so much what investors focus on. So I'm going to try to sort of pivot into here's what we like to invest in, but really focus on the themes of AI investing, not venture capital. And I like to call it Moonshots because these formerly discrete domains may actually be unifying in the not too distant future. So we are a venture capital firm called Future Ventures. We invest in startups that are trying to change the world for the better in a major way. And if you think about where that happens, it's always in a field where there's been disruption. Big picture, this is why democracies and deregulated environments tend to achieve more changes, because you have less regulatory capture, less of the big getting bigger, less authoritarian kind of regime protection, and more disruption. So we thrive in disruption. We look for it. We find it sometimes in new channels of distribution like the internet and mobility. We find it sometimes in deregulation, not so often, unfortunately. But most of all, we find it in the nonlinear exponential change and progress in technology. So that's really going to be my focus and segue to AI. Just a snapshot of what we've done the last couple of years since I last was speaking here. So it's been some AI investing, which, I include nuclear energy in that, or baseload power, and I'll get to why in a moment, because that may be the gating factor for AI's future. We've avoided, generally speaking, the application layer, because we don't invest in enterprise software that much. Find it kind of boring. And we don't really think history books will be written about any enterprise software application layer. I mean, in a strange way, like literally 20 years from now, will we even remember Oracle? Or will kids care? Or Salesforce.com, or pick any. Maybe that's just me, but I find it terminally boring. Instead, we're investing in weird things like analog AI, which we think is the ultimate computational substrate for AI. Infrastructure layers, like trying to improve open models or long context windows or edge AI. Some applications, but not much. Sphere Semi, for example, a recent investment's a very strange one doing generative AI for analog circuit design, which is synergistic with analog AI chips, but basically trying to go perhaps in a vertical that you wouldn't imagine OpenAI going into directly, like making the chips themselves. But let me move on to something more interesting. Now, I show this slide in every talk I ever give for over 20 years, but I always ask how many people have seen it. Ray Kurzweil's version of Moore's Law. I know it's a higher percentage. There's no way this audience doesn't know Ray Kurzweil's Age of Spiritual Machines. Like, this is the I don't know, the Bible, if you will. So he's maintained this curve for a while. It has a huge influence on me. It still does. For those who don't know, it's a logarithmic scale. How much computation does a dollar buy in inflation-adjusted dollars? What's astounding is that over 100 years, people have been fitting to a curve they didn't even know they were on for most of that time period. And this was Ray's version of it. To make it more interesting for everyone else, I've added some more data points. And it's kind of interesting. A straight line would be an exponential. This clearly is starting to look like a double exponential. And just for, against the sense of scale, this covers a 10,000 billion X improvement in price performance of computing. This is the substrate of AI futures. This is what allowed Ray to predict when a human would be beaten by a computer in chess, when we'll have AGI, which he still believes his original forecast from like 1998 is still true today, which is it's coming in the next couple of years. Oh, shoot, you can't read this, can you? Okay, well, you don't. The little things are noise. Imagine each of these is the best price performance computer of their day, roughly speaking. But interestingly, a substrate handoff from Intel to the NVIDIA's and G and Green. And NVIDIA chips are becoming more like ASICs, so they're distinct, custom circuits, if you will. The TPU 7 from memory, the Tesla Dojo, which then got canceled, the Tesla AI5 chip, and these two orange ones are interesting. Those are analog AI chips from Mythic that vastly outperform. Like, remember, a little bit like this is like at least a 10x, if not more. Yeah, you can buy this one. This one was started shipping in 2019. Two of these are not yet shipping. The Tesla chip is in final tape out, and the Mythic M2 is not yet available. That'll be 2026. So there's at least two data points, these two, that are forward-looking. The rest are not. But good point. TPU 7 is not forward-looking. It's shipping now. So that curve is super important because it has obviously disrupted a number of industries. In the 80s, the obvious ones, computing itself. And then as networking became data-driven, packet switch networks, and of course, what was analog before became digital, that really drove advances in networking and telecom. The current era, it's perhaps obvious, we think with Tesla and SpaceX, that the companies that matter in automotive are Waymo and Tesla. The ones that matter in space or SpaceX. There's been a major shift in those sectors, and I put Anduril and other drone-based defense companies in that same bucket. That's sort of obvious and happening. And in the not too distant future, we think a lot of other industries, most importantly AI, which we'll talk about for the rest of today, are radically going to change because of this. I won't belabor this, but you all probably know this pivotal event that occurred with the ImageNet competition in 2012 when we started neural nets and then what they call it deep learning. But basically, everything having to do with these connectionist, bottom-up kinds of models took over in training and compute. And it's been, going more than the 2x per year Moore's Law. So by the way, that curve I showed in Moore's Law, the main takeaway is 2x per year, no matter what Intel tells you, largely lately through architectural advances. But then AI compute per model, and then even spending per model has been going up roughly 10x per year for 10 years. So, what are some unmet needs? We don't try to invest in the heat of the herd, if you will, with perhaps the exception of XAI with Elon's company. Because someone has a shirt, "Don't bet against Elon." That's been my life motto. To give you a sense of what analog can do, this to your question, 2019 chip, 2019 architecture, major advance. Their next generation, and also a 40 nanometer process, by the way, this one. So a really archaic process node. If you switch to a modern node, they get like another 65x advantage on top of this, which is what they're in the midst of doing. And it was really inspired by the brain itself. A lot of AI has been. I'm going to check my watch as we go. And the idea of a mythic, and I think they're now still the only one really pursuing this, although IBM's doing a lot of research on it, is that you can do in-memory compute. You can do the 8-bit multiply and add that is the fundamental workhorse of all AI in a single transistor. And for anyone in EE, that's like, how can you do a multiplication operation on 8 bits of data and add all in a single transistor? It's a flash memory cell where the gate voltage multiplies by the floating, the gate voltage by the floating gate voltage that has been stored there. So you store your weights, the activations are coming in, and it just drops a current on a wire. It's the multiplicand of those two as the current. And they've got this shown to work, and it gives you somewhere between 100 to 1,000x power advantage, and as well about 10 to 100x compute advantage. Now, Jensen over at NVIDIA, really, this is not a quote he made related to any product they were developing. He thinks this is other people's chips like Mythic and others that are going to put these little jelly bean, 40 cent, less than $1, think price point, chips into everything. Every video camera, obviously every humanoid robot, every car will be an intelligent edge device. And that is we think the big untapped AI opportunity that is just latent and sitting out there and has not happened yet. Industrial sensors, all these things are still way behind in terms of rolling AI into everything, and it will be into all kinds of things. I won't even belabor that. It's kind of an obvious point. But why is it sort of interesting? So some of the reasons, maybe at a high level, is you can think of it as this reactive sensory cortex, not just the big thinking thing, but things that are more akin to pre-processing in the visual cortex or reflexes, where you can basically first win in a product category if you're smarter. So we think people only purchase cars or choose cars. How does that mean 1 minute left? Okay. Based on how much intelligence they have inside. The only purchase decision for a car will be the AI software stack for autonomous driving. You can obviously have lower latency for voice interface on everything. You can have robust offline use when you don't have an internet connection. And then this privacy local data thing relates to the earlier questions we're having. We think that's obviously going to be Apple's late play into AI when they really dropped the ball for a while, but they're waiting for the moment when you would trust your phone, not Apple, but your phone to do all of your executive assistant functions, health knowledge and what have you, and be sort of your trusted assistant. Now, it gets kind of crazy when you look at the aggregate spend in this area. Just a few data points. Data center CapEx is now over 1% of US GDP. This is not AI. This is constructing the buildings and putting the HVAC systems in the power grid and buying the chips to put these data centers together, and it's exploding. McKinsey, one random group, believes it's going to go to $6.7 trillion by 2030. Again, this is the CapEx. But what it's being choked by is electricity. And you'll see this, of course, in people doing forward purchase agreements for fusion and fission and all kinds of different things. To somewhere over 10% and growing of U.S. electricity. But this problem is, it's not a generation problem. It's a transmission and local use problem. So you are seeing an incredible run on the market for natural gas-driven electricity turbines. They're sold out for 8 years now. You have 146 natural gas-fired power plants in construction where it was 0 just 5 years ago in their forward-looking forecast. and we can't build it fast enough. So there's a thesis around that has us interested in where we might take that. And one of the interesting investment theses that we're realizing is now, because the latency has gotten low enough, and there was a big breakthrough this year just on a software update they did. Oh wait, is this a build slide? Yeah, that Starlink basically allows you to have a data center for inference anywhere you want. So the latency is good enough with Starlink now that you don't need the fiber attach, which means if you had a nuclear power plant, wherever they'll let you build one, or a fusion plant, or a hot rock deep geothermal well, wherever the geothermal is best put your data center there if you have the energy, and use Starlink to serve inference wherever. An extreme example of this is not an investment of ours, but a really intriguing thought experiment is this company building floating autonomous data centers that will be in the southern hemisphere, just at the place where Starlink is peak availability, and there's almost no competition for bandwidth, and just run these autonomous things that power themselves off wave motion that are free floating in the ocean. Well, that's an exciting new opportunity. But the really big one, of course, is, well, if you can put them anywhere, how about put them in space where you can have perpetual sunlight in a sun-synchronous 1,200 kilometer orbit facing the sun, with no occlusion, no battery storage, because you're always in the sun, for a variety of reasons, somewhere between a 5x, maybe more cost advantage per in terms of watts per of compute that you can put up there per dollar. And it's obviously the darling now of Elon, and strangely at the same time Bezos and Eric Schmidt, who all really think this is the future. I was not a fan just a few months ago, and then did a lot more thinking around and research with Grok, actually, of all things, on what the size of the heat fin would need to be to make the heat dissipation work. And it's actually not as bad as I thought, by far. It's very doable. And then it just becomes a chip reliability issue. But the ASICs do better than GPUs. So don't assume these are going to be based on any NVIDIA chips, in my opinion, for reliability reasons. So let me end it there and go to Q&A just to say, I think AI, the bottleneck and this grand unification with space is very interesting. I mean, Elon's talking about like 300 gigawatts per year of data storage data compute capacity being put up. This is, a fairly large fraction of the entire U.S. grid per year. And then to take it to the next level, of course, put a mass driver on the moon, build solar panels from the abundant silicon, iron, and oxygen on the moon, and just shoot them into orbit to get to much larger numbers of compute, with an ultimate goal to, of course, start the original Foresight dream of, the Computonium everywhere.
What could possibly go wrong? Thank you.
Exactly.
Okay, we have time for a very quick question.
There's one in the back?
Yeah, I'm just trying to see if there's someone who hasn't asked one yet, but I'm running to you. You are in luck.
Hey, Steve, great presentation.
Thanks.
I've heard Elon allude to, starting possibly with AI 6, that the dream is to push both training and compute to the edge. With the amount of CapEx spend that's currently being spent, several trillion, do you see any risk of stranded assets in terms of those investments, if that ends up being the case?
Was stranded where?
Stranded assets, like data center CapEx not being maximized or usable if we're pushing so much of training and compute to the edge as you envision.
Gotcha. Personally, I don't think so, because I think there's no upper bound on how much compute we want. So it would, like, the argument, what he's saying is, when you have all these AI 6 chips in the vehicles, and you think about the number of vehicles that are out there, wow, wouldn't that be an incredible distributed compute resource that you could use? And you've seen precursors of this idea with, SETI at home and other distributed, like you have stranded GPUs in the home and in certain businesses. That aggregation has a couple of challenges. One is that it's not coherent compute. There's, periodic access based on where people are driving. So there's almost a bifurcation of things you could farm out, and you could probably piece together a fairly interesting inference. And for the macro hard product, which is what they believe that XAI was going to be their major revenue driver in the future, this idea of humans being, like white collar jobs being replaced by a virtual employee, that you could imagine per compute cycle, you could have several of those virtual agents working. So the agentic macro hard vision, yes, could probably serve by a number of cars, but still training, you're going to want the huge coherent clusters like they have the gigawatt one currently in Memphis. And I think, with all the other efforts, there's still going to be, overwhelming need. So I don't worry so much about stranded assets as much as a rapid obsolescence cycle, perhaps, on training, less so on inference. And yeah, I do. Put it this way, we're not investing in that CapEx. Like, I don't get that business model at all. like, wow. But God bless them. Someone loves that, and they're plowing money into it.
Thank you so
Sure.
much. Awesome. That was amazing.